Mastering Python Part 6. It's a part of the series having 100 plus solved exercises to accelerate the learning. In Part 6, we will discuss about the recursive functions. We know in Python a function is a block of reusable codes that perform a specific task, and this function helps us in organizing code, improving code reusability, and reducing this code duplication, which allows you to break down a complex problem into the small manageable parts. So here we will discuss all the programs which are related to recursive function here. So first program is write a recursive function to calculate the factorial of the number. So here the factorial function takes an input n, which represents the number for which we want to calculate the factorial. And the base case is defined when this n is equals to 0 or 1. In these cases the factorial is defined as 1. In the recursive case, the function multiplies n by the factorial of n minus 1. And this step will recursively call the factorial with a smaller value of n until it reaches the base case, and function returns the calculated factorial value here. The next program is to calculate the Fibonacci sequence up to a given number. So here the Fibonacci function takes an input n, which represents the number of positions in the Fibonacci sequence for which we want to calculate the value. The base case is defined when n is equals to 0 or 1 here. In these cases, the Fibonacci values is defined as 0 and 1 respectively. So in the recursive case, the function calculates the Fibonacci value of n by recursively calling the Fibonacci function with n minus 1 and n minus 2 and adding the results together. And finally, it returns the calculated Fibonacci value. The next program is to create a recursive function to check if the number is prime. So the is_prime function, it takes an input n and an optional parameter divisor to check if n is divisible by divisor or not. So the base cases are defined as follow, like if n is less than equals to 1, it is not a prime, so we return false. If n is equals to 2, the only even prime number, so we return true. If n is divisible by the current divisor, if it is not prime, so we return false. If the square of the divisor is greater than n, we have checked all possible divisors and n is prime, so we return true here. And in this recursive case, the function calls itself with the same n and increments divisor by 1, and the function returns the results of recursive call here. The next function is to calculate the sum of the digits of an integer. Here the sum of the digits will take an input n representing the integers for which we want to calculate the sum of digits. The base case is when n becomes 0. In this case, there are no more digits to proceed, so we return 0. In the recursive case, the function extracts the last digit of n using the modulus operator and add it to the sum of remaining digits. The function calls itself with the updated value of n obtained by the integer n divided by 10, which removes the last 10 digits. The recursive call continues until the base case is reached, and the function returns the sum of the current digit and the result of the recursive call. The next program is to calculate the power of integer raised to the exponent. So here this power function takes two arguments, base and exponent, representing the number and the power to which it is raised. The base case is when exponent becomes 0. In this case, any number raised to the power of 0 is 1, so we return 1 here. In the recursive case, the function multiplies base with the result of recursive call to power, where the exponent is decreased by 1. So recursive call continue until the base case is reached. So here the function returns the result of multiplying base with the power of base exponent minus 1. The next program is to find the greatest common divisor of two numbers. So here the GCD function takes two arguments a and b, representing the two numbers for which we want to find the GCD. The base case is when b becomes 0. In this case, we have found the GCD, which is a. In the recursive case, the function calculates the GCD of b and the remainder of a divided by b using a Euclidean algorithm. and the recursive calls continues until the base case is reached. The next program is to create a recursive function to reverse the string. So here's the reverse string function takes a string as an argument. The base case is when the length of the string is 0 or 1. In this case, there is no need to reverse the string, so it is returned as it is. In this recursive case, the function recursively calls itself passing the substring starting from the second character and then appends the first character to the original string. The recursive call continues until the base case is reached and the reverse substrings are concatenated to reverse the entire string, and the function returns the reverse string. The next program is to find the smallest number in the array. So here find smallest function takes an array R as an argument. The base case is that when the array has only one element. So in this case, there is no need to compare, so the single element is returned as the smallest value. In the recursive case, the function compares the first element of this array with the smallest number in the rest of this array. The recursive calls continues until the base case is reached and the smallest values are compared and propagated back up. The next program is to determine whether words is a palindrome. So here is palindrome function takes the word as an argument. The base case is when the word has 0 or 1 character. In these cases, the word is considered a palindrome, so true is returned. In the recursive case, the function checks if the first number and the last character of the words are equal. If they are equal, the function recursively calls itself with the remaining substring word 1 minus 1. To check if the substring is also palindrome, the recursive call continues until the base case is reached and the results are propagated back up. So if at any point the first and the last characters are not equal, the function returns false as the word is not a palindrome. The next program is to calculate the sum of elements of an array. So here the vector sum takes a vector list as an argument. The base case is when the vector list is empty. In this case, sum is 0. So we return 0. In the recursive case, the function adds the first element of the vector to the sum of the remaining elements here. To calculate the sum of remaining elements, we make a recursive call to the vector sum with a slice vector 1, which represents the vector without the first element, and this recursive call continues until the base case is reached and the results are propagated back up. Thank you.